Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 4th, 2025, just yesterday. It introduces a clear framework for conflicts in multimodal large language models, showing a universal law where the chance of following a modality steadily falls as that modality's relative uncertainty grows, and identifying a balance point that cleanly captures inherent preference. The paper is titled, When Modalities Conflict, How Unimodal Reasoning Uncertainty Governs Preference Dynamics in MLLMs, and as we will see later, the implications for model training and evaluation are quite significant. Figure 2 shows that as task difficulty rises, unimodal entropy climbs, confirming it as a good uncertainty gauge. Entropy here means how spread out the model's answer probabilities are, so higher values signal more doubt. The left panel presents text modality trends, which rise steadily with difficulty. The right panel covers vision modality, which increases even faster, reaching about 1.5 at the hardest tier and separating stronger from weaker models. Alright, Figure 1 presents the overall setup for testing how models choose between text and vision in conflict. The left panel shows controllable difficulty for each modality, so the same question can be easy or hard depending on the input. The top right panel measures perceived uncertainty using entropy, which rises when the answer distribution spreads out. The bottom right panel defines relative uncertainty, a single axis comparing text and vision confidence. Moving to results next, this axis will let us read off inherent preference at the balance point. So, Figure 4 shows that modality choice tracks confidence gaps, not brand identity. The left panel plots text preference against relative uncertainty, and the curve drops steadily, crossing the 50% line at a model-specific balance point that encodes inherent preference. The right panel confirms robustness by splitting cases into low and high entropy subsets, and the same smooth monotonic trend remains. Together, these curves turn noisy ratios into predictable behavior. Well, Figure 5 shows that models flip between text and vision answers much more when the case is ambiguous. An oscillation means the layer-wise top answer switches between the text-supported choice and the vision-supported choice, which signals indecision. Patterned bars rise notably above solid bars across models, so ambiguity drives extra flips. The irrelevant conflict control stays low, indicating the spikes come from real semantic contradiction, not sentence form. We just saw that ambiguity increased oscillations. This table defines the visual difficulty tiers that generate those ambiguous cases. The tiers use two levers, the number of objects in the scene and the target object size. Lower tiers keep 3 to 4 or 6 to 8 objects with a large target, which makes recognition easier. Higher tiers push to 6 to 8 or at least 10 objects and shrink the target to small, so vision becomes harder and uncertainty rises. Alright, 2 takeaways stand out. Modality choice follows a simple rule tied to relative uncertainty, and the balance point offers a clean measure of inherent preference, separate from raw skill. These ideas enable fairer evaluations, better training curricula, and diagnostics for indecision via layer-wise oscillations. Thanks for listening. I am Alex, and this was the AI Research Roundup.